Greetings, human. We are Dogenites from the planet Her.
Turn off that music.
Sorry, my bad. We might look like humans, but we have taken the form of your species to make things less intimidating.
We have abducted you. But don't worry, you'll have the chance to come back to your planet. That is, as long as you have the intelligence to escape.
We have been highly curious about the level of intelligence that your species possesses, so we'll let you take a series of tests. If you complete them successfully, you'll get the chance to escape.
The test that you'll be taking is all about solving right triangles using trigonometric ratios and the Pythagorean theorem.
Does that sound familiar? We have made use of the concepts in this interesting subject on your planet called math, specifically the mathematical subconcept of trigonometry. You'll be making use of these earthly concepts to solve four problems that will determine whether you'll live or not. But before that, in case you've forgotten, we'll first explain to you such an earthly mathematical concept, even though you should already know this.
First of all, what is a right triangle? It is simply a plane figure with three straight sides and three angles. One of the angles measuring 90 degrees, which is the right angle, and the sum of all three angles always being 180 degrees. Therefore, the sum of the angles other than the right angle is always 90 degrees, making them complementary angles.
The parts of a right triangle are its three sides. The hypotenuse, which is the longest side, the opposite, which is the one across from a given angle, and the adjacent, which is the one next to a given angle. The sides of a right triangle are represented by lowercase letters. The side opposite to the right angle, which is the hypotenuse, which is the longest side, is always represented by side C, and the shorter sides, or the legs that intersect to determine the right angle, are represented by side A and side B.
On the other hand, each angle of a right triangle is represented by uppercase letters. Across side C, which is the right angle, is represented as angle C. Then, across side B is angle B, and across side A is angle A. Now, how do you solve a right triangle? What are we looking for? To solve a right triangle, you must find the measurements of all three sides and angles of a right triangle, or simply find what is being asked in the problem. To do so, trigonometric ratios are used to solve for the measurement of an angle given the measurement of two sides, while the Pythagorean theorem is used to solve for the measurement of a side given the measurement of two other sides.
Trigonometric ratios are defined as the values of all trigonometric functions based on the value of the ratio of sides in a right-angled triangle. The ratios of sides of a right-angled triangle with respect to any of its acute angles are known as trigonometric ratios. There are six trigonometric ratios, namely sine, cosine, tangent, and the reciprocals, which are cosecant, secant, and cotangent respectively.
Since we will mostly use sine, cosine, and tangent in solving right triangles, it can be very helpful to remember the mnemonic SOHCAHTOA, wherein SO stands for sine of the angle is equal to the side that's opposite to the angle divided by the hypotenuse. Ka stands for cosine of the angle is equal to the side that's adjacent to the angle divided by the hypotenuse. And TOA, which stands for the tangent of the angle, is equal to the side that's opposite to the angle divided by the side that's adjacent to the angle.
Lastly, the Pythagorean theorem is a well-known geometric theorem that states that the sum of the square of the legs, which are side A and B of a right triangle, is equal to square of the hypotenuse, which is side C. In algebraic notation, it is expressed as a squared plus b squared is equals to c squared. Both the trigonometric ratios and the Pythagorean theorem work hand in hand in solving right triangles.
For instance, when you're asked to solve for the measure of the hypotenuse in side A, given that angle A is 30 degrees, Angle B is 60 degrees, and side B measures 12 meters. We can use the mnemonic Ka from the trigonometric ratios to look for the value of the hypotenuse because we are given the value of side B and angle A. Thus, based on angle A, we write cosine of angle A, which is 30 degrees, is equal to side B, the adjacent side, which is 12 meters, divided by side C, which is the hypotenuse, the one we're solving for.
To make things simpler, cosine 30 is just the same as cosine 30 over 1. From that, we cross multiply. On the left side, 12 times 1 equals 12, and on the right side, we write C multiplied by cosine 30. Based on the unit circle and knowing that cosine is x, we'll know that cosine 30 is equal to the square root of 3 over 2. You can also use your calculator in solving such. So now, we have 12 equals C multiplied by the square root of 3 over 2.
To further simplify, both sides should be multiplied by the 2 over square root of 3. On the right side, the 2's and the square root of 3 will be cancelled. So on the left, we will have 2 times 12, which is 24, over the square root of 3. So now, we will have C equals 24 over the square root of 3. To rationalize, we simply multiply the square root of 3 to the numerator and to the denominator. We will get 24 times square root of 3 over square root of 3 times square root of 3, which is 3. In simplifying the answer, we will get C equals 8 square root of 3.
To find side A, we simply use the Pythagorean theorem. In substituting from the formula, we write a squared plus 12 squared equals 8 square root of 3 squared. 12 squared is 144, while 8 squared is 64. The square of the square root of 3 is just 3, and 64 times 3 is 192. So now we have a squared plus 144 equals 192. 192 minus 144 is 48. Now we have to square root both sides to find a. The square root of 48 is the square root of 16 times the square root of 3, which is 4, times the square root of 3. Therefore, side A measures 4 and square root of 3 meters.
Now that we've discussed everything you need to know, you are ready to take our challenge.
If you successfully finish it, we'll bring you back to Earth.
If you don't, you'll never see your little blue planet ever again.
3, 2, 1.
Level 1. In the aliens' headquarters, just outside of your imprisonment room, a camera is installed above for monitoring. The angle of the camera is set to monitor 38 degrees below the ceiling and has a blind spot below it. The camera only captures a maximum height of 16 meters. Determine the distance that the camera reaches to plan for a successful escape while remaining out of sight.
Congratulations, you got it right.
In order to determine the maximum distance that the camera reaches, we must first illustrate the given problem and substitute the given values. In the problem, it states that the angle of depression, or the angle which denotes that the line of sight is downward, is 38 degrees below the ceiling. Moreover, the maximum height that the camera captures is also given, which is 32 meters. With that, we can now substitute angle A with 38 degrees and side A with 32 meters, as stated by the given. Now that we have partially created an illustration, it is now time to solve for side C, or the hypotenuse, which will help us determine side B using Pythagorean theorem. Using the trigonometric ratio SO from the mnemonic SOHCAHTOA, we can make use of the formula to obtain the hypotenuse, or side C. Sin theta equals opposite, or side A, over hypotenuse, or side C. By substituting the given values, We can now create an equation and solve for c. The final formula will be sine of 38 degrees equals 32 over c, or hypotenuse. Simply cross-multiply and we now have an equation of hypotenuse which is equal to 32 over the sine of 38 degrees. Therefore, the hypotenuse or side C is equal to 64 meters. Good job, human! Now, we can finally proceed to the final step in order to know the maximum distance captured by the camera. This will be of most significance, especially for your great escape plan. The last step will be to solve for side B, which is the maximum distance captured by the camera. To solve for side B, we can make use of the Pythagorean theorem, which states that a squared plus b squared equals c squared. However, since the value of a and c are already given, we can make some minor changes to the formula to find for b. Therefore, the final formula would be b squared equals c squared minus a squared. Simply substitute the given values, and you will arrive with b squared equals 64 squared minus 32 squared. Solve for the difference and the answer will be 3072. To solve for b, we must square root both sides to eliminate the exponent of b. Therefore, we now have a final answer of b equals 32 square root of 3 meters, or approximately 55.43 meters. Be sure to take note of this, mere human, for it will be of great help to your future endeavors, especially in escaping this prison room.
Level 2. As you are abducted by the aliens, you are to be monitored by them. Thus, you are trapped in a room in point B that measures 55 degrees. On the other side, there is a tower in point C that is 250 meters tall with an alien that is located at the top of it. Since you have studied about the aliens before, you have known that their clear vision is only up to 250 meters. Therefore, what is the measure of the angle of depression based from the perspective of the alien? What is the distance of your room from the tower? What is the measure of side C or hypotenuse? And, the main question, will you be able to escape with the location you are in?
Congratulations, you got it right.
To know if you can escape or not, we need to illustrate the given for better understanding. First, it states that point B, where the room is, measures 55 degrees, and on the other side of point C, a 250 meters tall tower is located. Therefore, that would leave side A as the distance. And always remember that an alien's clear vision is limited only up to 250 meters. Second, computing for the angle can be solved by equating the three angles to 180. Since we already have two given angles, 90 since it is a right triangle, and 55 from your room, we can put it as x plus 90 plus 55 is equal to 180. Add both 90 and 55, that would be 145, and then transpose to make it 180 minus 145. Therefore, the angle A or angle of depression from the point of view of the alien is 35 degrees. The third step is using the trigonometric ratios, SOHCAHTOA. Based on the illustration, we will be using the tangent formula because we are given with the opposite side, which is 250, and we will find the distance of point B from point C, which is the adjacent. This step is very significant, so we can proceed to finding the hypotenuse, which will determine if we can escape or not. Going back, substitute the values of the angle, opposite, and the adjacent. It would be tan 55 degrees is equal to 250 over A. Multiply the A to both sides and then divide tan 55 degrees to make it A is equal to 250 over tan 55 degrees. Therefore, the distance of the room from the tower is 175.05 meters. The fourth and final step is solving for the hypotenuse using the Pythagorean theorem with the formula c squared is equal to a squared plus b squared. Substitute the values of side A and side B. That would be c squared is equal to 175.05 squared plus 250 squared. Square the values of A and B and then add them together to get the sum. Lastly, square root both sides to get the value of c. Therefore, the measure of side c is equal to 305.19 meters. Our final answer would be, the distance of your room from the tower is 175.05 meters with an angle of 55 degrees. And since the vision of an alien is clear only up until 250 meters of distance with an angle of 35 degrees based from his perspective, we can conclude that you can escape from the abduction because their view and distance from your location has reached the maximum clear vision, which is 305.19 meters based from the hypotenuse.
Level 3. You are in an alien ship shaped like a right triangle. You got the map of the ship, so now you know that you are trapped in a triangular room on point B. There is a tracker inside your body that sends a signal to the aliens once you have moved 6 kilometers away from your triangular room. You need to know the exact distance from your triangular room to the triangular room in point A, which contains a escape pod, so that you can find out whether or not you can still be detected by the aliens before you get to the escape pod. You also need to find out the distance from the triangular room in point A to the square room in point C, because it contains the button to make the escape pod launch in 5 minutes. As you measure the angle of your room, you found out that its angle is 60 degrees. You also overheard the aliens chatting that the distance from your room to the square room in point C is 0.25 kilometers. Are you going to be detected by the aliens before you get to the escape pod, launch it, and escape?
Congratulations, you got it right.
To solve for the hypotenuse given the angle and the adjacent side, the cosine formula should be used, which is cosine of the angle is equal to the adjacent side divided by the hypotenuse. In substituting the values that we already have, we're going to get cosine of 60 degrees is equal to 0.25 divided by c, which is the hypotenuse. In cross multiplying, we're going to get c is equal to 0.25 divided by 1 half. 0.25 divided by 1 half is equal to 1 half, so c is equal to 1 half. Therefore, the distance from your triangular room in point B to the triangular room in point A is 1 half or 0.5 kilometers. Since we already have the value of the hypotenuse, we now need to find the value of b using the Pythagorean theorem, which states that a squared plus b squared is equal to c squared. So we're going to get 0.5 squared plus b squared is equal to 2 squared. 0.5 squared is equal to 0.25, while 2 squared is equal to 4. In transposing 0.25 to the other side, we're going to get b squared is equal to 4 minus 0.25. 4 minus 0.25 is equal to 3.75, and now we need to square root both sides. Square root of b squared is equal to b, while the square root of 3.75 is equal to the square root of 15 divided by 2. Therefore, the distance from the triangular room in point A to the square room in point C is square root of 15 over 2 kilometers. Therefore, the distance that you'll need to walk to reach the escape pod in the triangular room in point A is 0.5 kilometers, while to push the button in the square room in point C and go back to the escape pod in the triangular room in point A, you'll need to walk square root of 15 over 2 kilometers times 2, which is square root of 15 or about 3.87 kilometers. From this information, you can know that the total distance you'll need to walk to escape is 1 plus 2 square root of 15 all over 2 kilometers, or approximately 4.37 kilometers. As a final conclusion, you will not be detected by the aliens before you get to the escape pod, launch it, and escape.
Level 4. Now that you're inside the escape pod and have already launched it, you have another problem. You find out in the manual that the escape pod launches in such a way that it first ascends at an angle of 40 degrees. The distance from the starting point to the top is 8 kilometers, and by that point, the escape pod will start to drop at a great speed. The space pod is mechanized to explode when it drops 6 kilometers from the above point. To determine whether or not you'll successfully escape and survive, you must calculate for the distance of your fall.
Congratulations, You got it right.
Not bad, not bad. What you just did was quite impressive. And to further explain your answer, sit back and listen. Firstly, we must locate all the necessary values that will be part of our solution. Observe from the illustration shown, side B is what was asked to find, and 40 degrees from the angle B and 8 kilometers as the hypotenuse for side C are the significant values that can be located. Secondly, determine which trigonometric ratio to use. In the given, we will be using SOA. We can create a formula to obtain the missing side. Take note that the reason why we're using such formula is because we are given the length of the hypotenuse and we were asked to find the missing value of side B. The formula is stated as sine theta equals opposite or side A over hypotenuse or side C. To move on our third step, let's create the equation by performing substitution on the values to the formula. So the formula should now be sine of 45 degrees equals to side B over 8. Next step would be multiplying 8 on both sides in order to cancel the denominator. When the changes are applied, it should now be 8 multiplied by sine of 40 degrees equals B. Now quickly grab a scientific calculator and input the recent equation that I have stated. It should now show you the final answer, which is 5.14 as the value of side B. Therefore, if based from the given, the height of the drop is just approximately 5.14.
Congratulations, human. You have successfully answered all of the word problems in mathematics. And as we promised, we will let you go back to Earth in 3, 2, 1.